Have you been called nonlinear but functional? If so, you have something in common with our SAT questions, and if not, that's perfectly okay as well. I'm happy for your linearity, or I'm okay with your lack of functionality. Nerdy jokes aside, God, do I still have you, or did I lose you already? Let's jump into some questions in this category of the SAT. The goal is to learn not just the answer to the question, but to learn more about the test. So a few things you could learn about the test. What things do they cover? What things do they not cover? What categories of questions seem to occur over and over again? You could wonder, how could I use the answer choices? That's some things we'll talk about a lot in all sorts of different categories. What tendencies do the test makers have, and what tendencies do they presume that students have, and how can we avoid sort of the worst things about those tendencies that students have? How can we use the tendencies of the test makers to move more efficiently, more quickly, and of course get more questions right? So let's start with this question. We have the value h of x equals 2 times the quantity x minus 4 squared minus 32. The quadratic function is defined as shown. In the xy plane, the graph of y equals h of x intersects the x-axis at the point 0, 0, and t comma 0, where t is a constant. What is the value of t? All right, so in a situation like this, probably the first thing to do is just sketch out like a really basic, don't try too hard, but like 0, 0 is a point on the graph, and another point on the graph that we know comes from this equation. And if you didn't know this, that's okay. This is vertex form. The center is at 4 comma negative 32. Okay, and that's really important that you can see that from this vertex form. You could say the general form of a vertex equation for a parabola would be, some value out front, parentheses x minus the x coordinate of the vertex, we'll call h, squared plus k. And here k means the y value of the vertex. So in other words, the vertex of this general form is h comma k, and the vertex of our specific one is positive 4, opposite sign in parentheses, negative 32. We also know that this point 0, 0 exists, so I'll graph both of those. So it would be roughly something like this, right? 4 comma negative 32. And forgive me, I'm going to probably do a pretty terrible job with this, but like something like that, where this is the other value that we're told about, which is t comma 0. Look, and this graph would extend up to infinity, and so would this. Okay, so here's the big important thing about this. Parabolas are symmetrical. So if you tell me that we have the value 0, 0, and then you tell me that the vertex happens at x equals 4, this distance of 4 should be the same distance to t, that distance of 4. So what does that make t? Of course, that makes it 8. So this question can go really fast if you know your stuff. If you know the vertex form, you immediately know 4 comma negative 32. If you know 0, 0, you should be able to say then, well, that distance from my value 0, 0 to the axis of symmetry is 4 units, right? Since the vertex is at 4. And then I can move 4 units further in the same direction to get to t, right? So that's a really fast way of doing that. Another way that you could do this question, it's worth seeing, is not graphically. You could just say, well, I have these 2 points. I could plug them into this equation. So to be clear, you could write the equation as y equals 2 x minus 4. I'll just leave a little space here. Squared minus 32. So we have 2 unknowns, right? I'll actually write the x in. We have y and x. But, we can put those values in. So for instance, you could put in the value 0 for y. And in fact, as I think about this now, it's like, if I want to solve for t, I don't actually have a second unknown. That's the only unknown value, right? So I could just do this. this would be another thing I can do, right? And I could do this math and solve. That should be sufficient. Let's walk through that work. Squaring t minus 4 is a dangerous moment. I oftentimes advocate just writing out t minus 4 times t minus 4 because you're less likely to make a mistake with the algebra that way. When you do the foiling, you'll get t squared minus 8t plus 16. That's all still in parentheses. So again, I wouldn't really recommend this method. It is worth being able to do this. Distribute the 2 will give you negative 2t squared minus 16t plus 32. And we have the minus 32 out here. So simplifying, those 32's cancel. You get 0 equals 2t squared minus 16t. I'm running out of space, so I'm going to go up here. I can factor a t out of my equation and a 2. 2t t minus 8. Okay, so now I can solve for values of t. And of course there are 2, right? That's why there are these 2 values where y equals 0 in both cases. When t equals 0, represented by what would happen if this t were a 0, you get 0 times, 0 minus 8. So that would give you one value that would work, but t is the other value. So what is that other value? Well, when this value is an 8, and of course it's both t's that are 8, would you get 16 times 0, 8 minus 8. So that's the algebraic approach, but you can see that if you just know your vertex form, you don't have to do all that work. And there's a lot of danger when you're doing this much calculation on the test. So the sooner you can recognize the axis of symmetry idea, the better off you are on this question and on the test overall. Okay, so this is a classic. Why do I say it's a classic? Because it's an easy trap that folks fall into, and it's an easy one to fix. Okay, so here's the big idea. I'll read the whole equation. The function f is defined by f of x equals negative 8 times 2 to the power of x plus 22. What is the y-intercept of the graph of y equals f of x in the coordinate plane? Okay, so the first thing to recognize is the answer choices make something super clear to you, which sometimes gets confusing for people. But the y-intercept is not where y equals 0, it's where x equals 0. That sounds really obvious when we say it out loud, but it's a mistake that I've personally made before. Maybe you have too. If you've ever made that mistake, or if you can conceive of that as a reasonable mistake, take active measures against it. If you have options where either x or y is 0, you'd want to think carefully about that. One of the ways I do that is I just do a sketch of basic coordinate plane. I show myself that y-intercepts could be at all these different spots. And the thing that's common about these spots is that, x is 0. Y could be anything, but x is 0. Okay, so once you feel clear about that, recognize that what you're doing is plugging a 0 in for x right here. And here's the danger. Recognizing that 2 to the power of 0 is 1. And recognizing that doesn't make this whole thing 1. It just makes it negative 8 times 1 plus 22. Okay, so that's negative 8 plus 22. And what does that get us? 14, right? So that's a really straight up question if you know what to do. Of course, one of the traps is thinking that 2 to the 0 is 0, which it's not, times negative 8, which would be 0, and then this is a really easy trap here, right? And there's some other mistakes lurking, particularly, thinking maybe something happens to cancel out this 22 in some way, but that's not the case. Let me explain to you why something to the power of 0 is equal to 1, because that's kind of a strange fact. So let's see. Let's say we had 5 squared over 5 squared. Now, that might be pretty obvious to you in one direction. You know that 5 squared is 25, and so I'll put 25 in both of these spots, and that simplifies to 1, right? 25 over 25 is equal to 1. But let's recognize this in a different way. If you know your exponent rules, then you could write this as 5 to the 2 minus 2, right? Because if you're dividing two values and they have the same base, you can just subtract the exponents, right? So to back up, let's say you had 5 to the 7 over 5 squared, or let's, to avoid confusion, 5 cubed. So 5 to the 7 over 5 cubed would be 5 to the 7 minus 3, or 5 to the 4. That's a property of exponents. If you know that, you can apply the same thing here and say this is equal to 5 to the 0, right? 5 to the 2 divided by 5 to the 2. 2 minus 2 is 0. So in one direction, it's clear to you that 5 squared over 5 squared is 1. And another move, you could make it clear to you that 5 to the 2 divided by 5 to the 2 is equal to 5 to the 0. So now you can see that both of these things are true. Maybe it was harder to see why 5 to the 0 or anything to the 0 is 1 before, but hopefully when you approach it from these two different directions, it makes sense. That brings up a general point I'd like to make, which is if you can understand something in two different ways, using two different modalities for explanation, or, sometimes that means doing algebra and using real numbers. Sometimes that means using logic and reasoning and then also doing a calculation. So if you can explain things in two different ways, then you actually really understand it and you're ready to use the knowledge in a more flexible way than someone who just has like one way of explaining something, right? So hopefully that helps. Generally speaking, what you'll expect if you didn't have this -8 value out front here, if you just had 2 to the x plus 22, you can expect that the y-intercept is 1 bigger than this 22. Now imagine, if you have that inflexible knowledge, which is, if I have an exponential equation, 2 to the power of x plus 22, I know that my y-intercept is, that final value of 22 plus 1. If that's the framework you're using, then you could fall into a trap very easily on a question like this, right? So flexibility is key, and the time to create flexibility is in practice. So don't be in a huge hurry to move past a question. Learn as much as you can about a question before you leave it behind. Okay, let's move on to another question. All right, here's an interesting question. This is a question that asks us to interpret equations or interpret aspects of an equation. Okay, so I'll read the question for you, and then I'll talk to you about method on this question. It says f of x is equal to 9,000 times 0.66 raised to the power of x. And the given function, f, models the number of advertisements a company sent to its clients each year, where x represents the number of years since 1997, and x is greater than or equal to 0 and less than or equal to 5. If y equals f of x is graphed on the xy plane, which of the following is the best interpretation of the y-intercept of the graph in this context? So what's the best interpretation of the y-intercept? Okay, so one of the approaches that I like to employ here is what I call the I'll edit myself for vulgarity here and call this the punk rock answer, or the wise Alec answer. My normal version of that is a little bit, let's say it's rated PG-13. So which of the following is the best interpretation of the y-intercept? What I mean by a punk rock or a wise Alec answer approach is to say the y-intercept is, when x equals 0, right? that has nothing to do with the particulars of this question, the answer I just gave, but it's taking one step in the right direction. Generally, I like to take difficult ideas and break them down into small pieces for myself and proceed in those small stages, right? So we're talking about when x equals 0, okay? That's what a y-intercept means. And you saw me do this on other questions, but like I just draw a little, I'll draw a little coordinate plane maybe down here at the bottom. Like a y-intercept is like a value here. It could be any of these values. It's where x equals 0. All right. So in this question, what is x? It's years after 1997. So what does the y-intercept represent? Like it represents something in 1997. So these answers look really good. These other ones don't necessarily look as appealing, though they could. You could word something about 1997 without talking about 1997, of course, right? Recall also that anything to the power of 0, we're talking about x equaling 0 here, is equal to 1, right? So the idea that we are talking about not 1997, I would say, okay, well, if we're not talking about 1997, we're certainly talking about the value that year. When x is 0, the value of the function is 9,000. So like this answer choice, which doesn't mention 9,000 or 1997, doesn't make a lot of sense. And this answer just is flat out wrong, right? It's not true that we're going to get this value in 1997. It's just not going to happen because when x is 0, we're in the year 1997. And when x is 0, this function is 9,000 times 1. Okay? So what does this y-intercept represent? Well, I mean, this is just true, right? That's true. And the idea is that f represents the number of advertisements. So that's 9,000, and the year is 1997. The reason B is factually wrong, it's like kind of on two levels. Number one, that's not the minimum value, right? That would be one reason. And the second reason why is the minimum value doesn't occur in 1997, right? 9,000 would actually be the maximum value because every time x increases, we're going to multiply that original amount of 9,000 by a decimal less than 1, right? We're going to multiply it by 0.66, which represents 66%. In other words, like the year after 1997, we're sending out 34% fewer advertisements, right? And then the year after that, we're sending out 34% less than that. I'm saying 34 because 66% is the remaining amount after you subtracted 34%, right? And one last little fun fact for those who are interested in language. Percent means per means divide, cent means 100. So 66%, the reason it's written that way, 66 per 100 is the 0.66, right? So that shows us the idea of percentages laid out in a decimal. Okay, so the punk rock approach, let's call it, to this question is, if somebody asks you what's the best interpretation of the y-intercept, start with saying x is 0. And after that you say, okay, well, what is x? Years. Okay, so years are 0, right? 0 years in this case after 1997. Okay, what's the value? 9,000 at that point. What does that value represent? It represents the number of advertisements, right? So that's how you would approach that question in a sort of piecewise manner, right? Proceeding by the smallest of stages. Let's move on to another one. Here's a really good one. The first term of a sequence is 9. Each term after the first is 4 times the preceding term. If W represents the nth term of the sequence, which equation gives W in terms of n? Let's recognize that we've got 2 variables and the relationship between them is, at least at first, seemingly obtuse. Like, why? That's a good question on a lot of SAT questions. Why are you wording things this way? And the answer is, the purpose of SAT math is not to test if your knowledge of calculus is on par with your peers, or if your knowledge of statistics is on par with your peers. It's to say, if we test folks at sort of a relatively low level of skill, can they problem solve and deal with some novelty, some strangeness in questions, right? That's actually what the SAT is about, even if they don't want to tell you that. I'll have more to say about that in a different context. My series, Essays on the SAT, talks about that. In the meantime, W represents the nth term of the sequence. Which equation gives W in terms of n? Okay. The best thing you can do here is try to ground your thinking in real numbers. The W represents the nth term of the sequence. Really weird. Let's just say that, let's start with just the nth term of the sequence, the first term. First term. Okay, so that's W represents the first term. So I think when n, the first term, the nth term, the first term, what is it? It's, let me set this up a little differently. The nth term, they're saying the nth term is W. Well, the first term is 9. That's one way of saying this, right? Okay. Well, in that case, we could say if the nth term of this is W and the first term is 9, call N1 and W9. Right? That will get rid of a bunch of answers because when N is 1, A is 4 times 9 or 36. No, W is 9 when N is 1. This one will work. 4, well, I spoke too soon. 9 times 1 minus 1. Well, 1 minus 1 is 0. That means this is 4 times 9 to the 0. That's equal to 4. We want it to be equal to 9. This next one, 9 times 4 to the 1. Again, that gives us 36. And then this one, D, is going to work. 9 times 4 to the 1 minus 1. Again, 1 minus 1 is 0. 4 to the 0 is 1. 4 to the 0 is 1. And 9 times 1, of course, is just 9. Right? So I made this really easy on myself by lining this up. The nth term is W. W represents the nth term. That's a confusing sentence. You saw me just start with being like the nth term. I got a little confused, but once I called N1, it was clear that the nth term, if N is 1, the nth term is 9. W is that 9. Right? So notice I used real values on that question because I had variables in the answer choices, and that's a great move to make when you've got variables in the answer choices, right? So I hope that helps. Notice that I also sort of started from the end of a complicated phrase, nth term of a sequence, and then I figured out W as opposed to going in the direction that they had originally presented the information in. That's probably a good move generally and something I tend to do quite a bit. Okay, so another question here. It says the function f is defined by f of x is equal to negative a to the power of x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x minus 12 has a y-intercept of 0, negative 75 over 7. The product of a and b is 320 over 7. What is the value of a? It's an interesting question. Recognize that they give us the function f, and they give us not the graph of f, but the graph of y equals f of x minus 12. Okay, so here's what I'm going to do. I need to combine the knowledge that they've given me in some sort of meaningful way, and these two equations seem useful. So I can write y equals, instead of f of x, I'll actually write this equation which represents that same thing. I'll put it in parentheses to be clear. That's f of x could be negative a to the power of x plus b minus 12. I know those parentheses aren't really doing anything for me, They are, however, making clear that I've inserted something in the place of f of x. In the place of f of x, I've written the equation for f of x, right? So that's a little bit of a substitution, if you will. We have a y-intercept given to us. We know that 75 over 7 is equivalent to negative a times 0, because this is an x value, plus b minus 12, right? Okay, fair enough. There's some things we can do here. I mean, first of all, we could add 12 to, we kind of want to get to these a's and b's, right? We want to get to the unknown values. So I'll add 12 to both sides, and that will give me negative a to the 0 plus b, right? And then I could do some common denominator stuff over there. I'll get to that. This is a really interesting and dangerous moment. This is sort of the heart of this question, if you will. It's that negative a to the 0. If I had my parentheses, I'll use a different color. If I had parentheses like here, this thing, negative a raised to the power of 0, would be equal to 1. But I don't. So it's negative. I could sort of write it like this. That's sort of what's implied. With no parentheses, we just presume that the exponent hits the closest term and nothing else. So that becomes something like negative 1. I'll put those parentheses here just to like emphasize that point too. But they wouldn't be there on the test. Or I'm sorry, they wouldn't be there unless you put them there, right? So let's just get rid of them now, but you've seen it now, right? Plus b. These parentheses are just here to show you the math that happened. And I'll do my common denominator work now. Negative 75 over 7, and then 12 times 7 would be 84, I believe. Oh, no. Yeah, 84. Right? 70 plus 14. 70 plus 14, that is 7 times 10 and 7 times 2. All right, so these add together to be what? 9 sevenths? And I'll now write my negative 1. I'll get rid of my parentheses because you're probably like, why? Why does this dude keep writing parentheses? Negative 7 sevenths is a common denominator version of negative 1, so that when we add it over on the other side, we'll get 9 sevenths plus sevenths equals b. And that means that b equals 16 sevenths. Okay. Right, that was just 9 plus 7. Now look, we have enough information now to do what we gotta do. A times b is 320 over 7, and we know what b is, so we can solve for a. This is 16 sevenths for b. There I go with my parentheses again, right? 320 over 7, and then you would just multiply both sides by the reciprocal. So 320 over 7 times the reciprocal of 16 sevenths. To be clear, what I'm doing is I'll use a different color. I'm multiplying 7 sixteenths. That cancels here. And 7 sixteenths here. Now our sevenths cancel. We have less work to do that way. And then 320 over 16 is the same as 32 over 16, you could think, times 10 over 1. So 32 over 16 is, of course, just 2 times 10. So this is 20. I know you could do some of that work with your calculator. I do think it's good to be able to do that work without a calculator, and not necessarily for the test when you're trying to move at speed, but for the sake of your own, math skills as a human being. Furthermore, using your calculator too soon can make you just rely on pressing a bunch of buttons as opposed to logically working through something, right? So if you got some horrible number for A, it might, you might trust it when you might otherwise not trust it, considering that we have like these divisors of 7 right? If the product is that and the B value is that, then A is a nice, easy number. And that makes sense, right? So, okay, cool. I hope that made sense to you. The key here was the mistake that I highlighted at this moment, right here. That's where everybody's going to go wrong. All right, let's move on to the next one. Okay, so this question says the function f is defined by f of x equals a to the power of x plus b, where a and b are constants, kind of similar to the last one. In the xy plane, the graph of y equals f of x has an x-intercept at 2, 0, and a y-intercept at 0, negative 323. What is the value of b? So a similar question we'll walk through. There's a couple of things we know. Essentially a system of equations. We can now plug these values directly in. So we can say, for instance, f of x, which equals y, is a 0. And that equals a to the power of 2 plus b. So what I just did is take these values for x and y. Right, here's the y. Here's the x. The other thing I know, and I'll do it in a different color, is I can apply these values to the equation. So I can say there's a y value of negative 323 when a to the power of our x value of 0 plus b. And what this represents is a system of equations, right? I mean, like, this is the one that we can actually attack first because anything to the power of 0 is 1. So now I can tell you that negative 323 equals 1 plus b. I can subtract the 1 and get negative 324 equals b. Okay. So then, I guess the truth is I didn't know what was going to happen here, but now it seems quite obvious, right? I'll just bring this down to the same line level. A squared, I still don't know what a is, but I do know what b is, which is negative 324. Okay. Now, if that's the case, I can say, well, if I add 324 to both sides, I get a squared equals 324, and I can take the square root of 324. Now, do I know the square root of 324? It's more than 10, since 10 squared is 100. It's less than 20, since 20 squared is 400. It has to end in a 4. Maybe 18? Maybe 18. The way I'm thinking about that is like, okay, well, 12 times 12. That'd end in a 4, 2 times 2, but I know what that equals. That's 144. 13 would end in a 9, right? The 3 times the 3 would end in a 9. 14 would end in a 6, right? 4 times 4 is 16, so the last digit is 6. I'm doing that work only I kind of, once 12, I thought about 12, which gets me so low relative to 324. I realized I should probably start from the other end. 19 didn't work, but 18 does. And as I sit and think about the remaining ones, there's no other value, so it must be 18. 18 equals A. Unless A equals negative 18. But again, I should have looked at my question. I don't even care about that. Here's all I care about, right? What do we know? Just out of pure interest, we have an x-intercept at x equals 2, y equals 0, and a y-intercept at 0, negative 323. So our graph's going to do this, I think. Whereas x grows, I suppose it'll do like that. Right? Okay. So I believe we've got our answer here, right? B is negative 324. The rest of it didn't matter. And I just modeled accidentally a mistake that we should all be aware of on the test, which is I spent time doing math that didn't matter, right? All I needed to know was the value of B, right? And what I should have done at the beginning is highlight the question so that I make sure that I attack the question directly, right? Notice the second equation that they gave us, or the second actionable item, that is the y-intercept, the second coordinate set that they gave us, was actually all we needed. We didn't even need this first one, right? It's kind of a classic in that way. Okay, so here we have another interpreting equations question. I'll read it to you, and if you'll remember from the last one of these we did, I have like sort of a punk rock way of doing this, or a wise Alec way of doing this. I'll explain what I mean in a second by way of a story, but let me read f of x for you. F of x is equal to the negative 500 times x squared plus 25,000 times x. Question says the revenue f of x in dollars that a company receives from sales of a product is given in the function f above, where x is the unit price in dollars of the product. The graph of y equals f of x in the xy plane intersects the x-axis at 0 and a. What does a represent? Okay, so there's all sorts of work you could do here that's totally unnecessary, because all we care about is the intersection at the x-axis. And the one thing that I would highly recommend doing here, as in most cases, is like just remind yourself what that means. That means we're talking about spots on the x-axis. That's where y equals 0, right? Or f of x equals 0, right? So this is just generally true. I haven't tried to think about the actual intercepts on this graph, but that's just what we're looking for. When does y equal 0? That's really all we care about. When y equals 0, the value of x when y equals 0. Okay, well, what is y? F of x. What is f of x? Revenue. When is revenue equal to 0? So check it out. These answers play with that idea but are wrong. The revenue, when the unit price is 0? No, unit price is 0. Unit price, I believe, is x. Yes, if we look right here. X is the unit price. We don't care about that. We care about when the revenue is 0. We're not looking for a max revenue, since we certainly hope max revenue is more than 0, and indeed it will be. I can explain why in a second, but to just stick with our point, the unit price that will result in the revenue of 0 exactly, and the max revenue, again, not what we're talking about. Now, let me explain what I mean by this approach. Have you ever been in a class where a teacher sort of is losing control of the class and tends to rely on like a smart person to answer all the questions? The wise Alec answer approach that we're using here, that name comes from my experience being a student in a class like that, which is I got really sick of a teacher relying on me in that way, and I just started giving him really, really sort of punk answers. So he would ask me something and I would just, give him the most annoying answer I could that was true but didn't really further the conversation, because I was sick of what he was asking of me, So I won't belabor the point, but the idea is to just answer this question not in the way that the answer choices frame it, but in the most basic way, and then add a little bit of information with each cycle. So what does A represent? When y equals 0. What does y equals 0? When f of x equals 0. What does f of x equals 0? That's f, the revenue is 0. And then I looked for that answer. To, sort of clarify something I said earlier, which is this is definitely not the max revenue. The reason I know it's definitely not the max is because I know a thing or two about quadratics. This negative in front of the x squared means it opens down. And if it has a point here and here, and this is a comma 0, and this is 0 comma 0, and if it has two of these points, then there's definitely a high point in the middle, right? So the high point is in between, and that's certainly above revenue equals 0, since revenue equals 0 is on the x-axis, right? When f of x, when the y value is 0. Okay, so that's another one of these interpreting equations questions. Let's continue on. Okay, so growth of a culture of bacteria. we live in a culture of bacteria. No, sorry for the bad joke. Entertaining myself, if not you. So we have this table with 3 days listed and the number of bacteria per milliliter at the end of each day listed in scientific notation. This is a really good question. There's some real challenges here. Now, you could take a brute force approach to this, and it wouldn't be the worst thing. I mean, the first thing you might do is rewrite day 3 as maybe 10.0 times 10 to the 5th. That might help you realize the relationship, which is a doubling from 2.5 to 5, from 5 to 10. We've got a doubling, right? So we could continue that. We could talk about on day 4, you could say you have like 20 times 10 to the 5th, and then day 5, you have 40, and day 6, you've got 80, day 7, you've got 160, day 8, you've got 320. And by the way, I kind of kept going here because I just presumed that the answer is probably going to be B, C, or D, considering how close these days are, and probably C or D. So I just didn't pick up my head to think too much about this until I got up here because I wanted to see where I am on day 9. So again, we just doubled 2, 5, 10, 20, 40, 80, 160, 320, 640. This is 640 times, just like the rest of these, 10 to the 5th, right? Which is actually 6.4 times 10 to the 7. All right, we want to get, a magnitude bigger than that, almost, right? We almost want to multiply that by 10. So we still got to keep going. Day 10, I'll use my scientific notation here so the numbers don't get too out of control, since I've already done that math. And just to be clear, 640, you move the decimal point over 2 spots, you move your exponent up 2 spots, right? You could check to make sure that these are the same value, but they are. So then this would be 12.8 times 10 to the 7. And then day 11 would be 25.6. That's just double 12.8 times 10 to the 7. And I'll just give us day 12 too. That would be 51.2 times 10 to the 7. Now here's where this question gets interesting, and I've seen this before. This is at the end of each day. Okay. So here's day 11 at the end of the day, which, we'll change this into proper scientific notation by moving this over, the decimal over 1 and the exponent up 1. So at the end of day 11, we're not quite there. That means on day 12, it looks like at the end of the day, we're exactly where we wanted to be. Okay, so that's a brute force approach, but it's also a fairly efficient approach, right? Because it's not like you had to think too hard about that, and you could just crank out those numbers. When I'm explaining things, obviously that takes a little longer than when you're just writing down and reasoning on your own, but that's one approach. The other approach is to actually be able to build this equation. It's not something that I would generally recommend doing. You saw what I just did at first glance on this question, but I will show you how to do that. Before I do, however, I just want to flag one thing. The practice materials we have for the SAT are the materials that the College Board has given us. And they're great, but they're not going to show us everything. Like the little tricky things that the SAT likes to do on the test, they probably aren't going to present to us in some of the practice materials. Why does that matter? Well, because what if they asked us, what if they did 2 things? Like what if this is at the beginning of the day instead of the end? If these numbers all represented the amount at the beginning of the day, and let's say they ask, when did we reach, like, instead of this, what if they just said 5 times 10 to the 8? Right? That would mean that if this is the amount at again, on our question, it's at the end of the day. But say it was at the beginning. If this was at the beginning of the day, then it would reach a number slightly smaller than that, but more than day 11's starting point sometime on day 11, right? So even though 5 times 10 to the 8 would be closer to the day 12 starting point, it would technically happen on day 11. And that bit of reasoning would probably be present on the hardest SAT questions, because you could do the calculation right and get it wrong, right? You could do the calculation entirely right and then think, oh, that's really close to day 12, right? So the language would matter, right? So that's a key to this question. Now, if you were doing this as an equation, the thing you have to get to is you have to recognize the y-intercept thing, which is to say when, it'd be something like, usually you set up an exponential equation with the growth rate, which is we're doubling, times some exponent. You have to think about when this equals 0, what do we want to get, right? So I guess when this is 1, we know that should be 2 times something equals this amount, right? To solve for that equation, you just do half of that, 1.25 times 10 to the 5th. And then this becomes an exponent, x, or t, right? So day 1 is that. Day 0 would be half of that, right? So this equation, I think, should work for, that would be your set. And then you would, essentially say 5.12 times 10 to the 8 equals 2 to the power of x, and then this. Now you could solve it. Of course, you could just divide both sides and solve for x, right? And if I've done things right, then the answer is D, right? X is 12. All right, cool. Let's keep moving here. All right, this is a great question. F of x equals ax squared plus 4x plus c. In the given quadratic equation, function a and c are constants. The graph of y equals f of x in the xy coordinate plane is a parabola that opens upward and has a vertex at the point hk, where h and k are constants if k is less than 0, and f of -9 equals f of 3, which of the following must be true. The key fact here is this one. That's the place to start. The axis of symmetry has to be halfway between those points. Essentially, if we know that those have the same y value, which is what it means for f of -9, which is a y value, right? -9 is an x, f of that, y equals f of some x value. The y value at x equals -9 is equal to the y value at x equals 3. We don't need to know what that y value is to know that the vertex is halfway in between, because parabolas are symmetrical. So whatever that value, the hk value, the vertex, is at -3, comma, some unknown k value. Okay, so the reason that's a great start is we need to know how to use standard form to talk about the x-coordinate of the vertex. The quadratic equation is -b over 2a plus or minus the square root of b squared minus 4ac over 2a. And I wrote it as 2 separate pieces as opposed to everything over 2a to show you that this is the x-coordinate of the vertex. And then we add or subtract the same amount to get to a symmetrical spot on either side, right? So in other words, -b over 2a is the x-coordinate of the vertex, and because you're adding or subtracting some amount to get to the values here, which is what the quadratic solves for, that's a proof, or a very basic proof at least, that -b over 2a is the x-coordinate of the vertex. If you know that, you take your standard form up here. This is ax squared plus bx plus c. b is 4, so -4 over 2 times an unknown a value, but it is a positive a value, is equal to the x-coordinate of the vertex, which we know to be -3. We can use that to solve now, right? We can say negative 4 equals negative 6a, and then we can divide by negative 6 and reduce, and we'll get 2/3 is equal to a. So we literally know what the a value is now. Okay, so is a greater than 1? Like, no, it's not 1. It couldn't be true. Not only must it not be true, but it is factually untrue. And so I can cross off anything that includes this. And now I have to figure out if 1 must be true or if neither is true. So we're wondering about the c, which is the y-intercept. Now, my graph makes it look like the y-intercept is definitely below 0, but I don't know. That's because I put these points where I put them. I could move the whole graph up and just make it like a stretchy graph. There's no reason why. I don't know, just based on my, sort of basic sketch of the graph, that this is accurate. So I'll draw in blue. You could have like, the y values up here or something, and you could be like, like that or something. Why not, right? It could be there. So we don't know, but we can use the other part of the quadratic, b squared minus 4ac. If this is positive, we have 2 solutions. If it's 0, we have 1 solution. And if it's negative, we have no solutions. I'll explain that just by saying that if you have a negative value under a square root, it's not a real value. So you can't add or subtract not a real value. So if it's negative, you have no solutions. And if it's 0, adding or subtracting the square root of 0 doesn't change anything. So you only have 1 solution. If it's any positive number, the square root of a positive number is positive, and you add or subtract that amount to get 2 solutions. Okay, so why do I care about that? Well, because now I know that because it opens upward and it starts below the x-axis, which is that k is less than 0 piece, I can tell you that b squared minus 4ac has to be positive because it starts below, it goes up, it's going to hit the x-axis twice. There's going to be 2 solutions, in other words. We know what b is, it's 4. We know what a is 2/3. We can solve for c such that this is greater than 0 since it has 2 solutions. So this is 16 minus 8/3 is greater, 8/3 c, is greater than 0, right? So I just did some of the math here. That's, now you could say 16 is greater than 8/3 c, and you can multiply both sides by 3/8 times c is greater than c times 16 is greater than c. This cancels to be 3 times 2 is greater than c. So c is less than 6. But we don't know how much less than 6 it is, right? So for that reason, can we say that c is greater than 0? No, because it could be smaller. So what must be true? None of this must be true. It's a great question. It shows you that thinking about the quadratic as 2 pieces that are both valuable for separate reasons, that is the key. Okay, cool. I hope that's helpful, and more to come.